In this video, we're going to start chapter 5.4, which is the sum and difference identities for sine and tangent. All right, so we've already done the sum and difference identities for cosine. So these are the ones for sine and tangent. We're going to go through and do similar problems in this section that we did for cosine in the other section. So if you want to see a proof for the sum and difference identities for sine, go to your book, go ahead and read pages 215 and 216. That proof is really short and sweet because it uses the concept of cofunctions, and the cofunction of sine is cosine, and we've already done the complete proof for cosine. So they just use the cofunction to prove the sine of the sum of two angles or the difference of two angles. For tangent, they don't necessarily do a proof, I don't think, or maybe actually they actually do go through a brief proof in the book for tangent. So if you're interested, you can go ahead and look at that to see how they came up with those formulas. But these are the formulas for the sum and difference of angles for sine and tangent. Just as in the last section, I told you that you didn't have to memorize the sum and difference identities for cosine. You don't have to memorize the sum and difference identities for sine and tangent. They will be given to you on an identity sheet that you can use on your test. Remember though, you have to memorize the cofunction identities and all of your Pythagorean, reciprocal, quotient identities that we've learned in the past. Those will not be on your identity worksheet. All right, so let's go ahead and start with some examples here. So keep those formulas next to you when you're doing your homework, because the real goal here is just to make sure that you can use those. It says use identities to find the exact values of the tangent of negative 105 degrees. So I know keep your unit circle out too. You've got a whole bunch of angles in degrees on your unit circle. What two angles might add to negative 105 or subtract to negative 105? Well, I'm going to just go ahead and use the tangent of negative 45 degrees minus 60 degrees. Okay, so I'm going to go ahead and use my tangent of the difference of two angles formula. So I have the tangent of negative 45 degrees minus the tangent of 60 degrees. Okay, so here my A angle is negative 45 degrees, right? I'm subtracting my B angle, B equals 60 degrees. And that's going to be over 1 plus the tangent of negative 45 degrees, tangent of 60 degrees. And what do I know about tangent of a negative angle? Well, that equals the negative of tangent of the angle. So I'm just going to rewrite this in terms of its positive angle. Negative tangent of 45 degrees, tangent of 60 degrees. And I know that the tangent of negative 45 degrees, or the tangent of 45 degrees, is 1. So I get negative 1 minus, what's the tangent of 60 degrees? Well, 60-degree triangle, we have 1/2, 30 degrees, 1/2, and rad 3 over 2. So it's going to be opposite over adjacent, rad 3 over 2 over 1/2, which is just radical 3 minus radical 3, and you have your unit circle that you can use. And then I have 1 plus negative 1 times radical 3. So remember, when we do this, we have to rationalize our denominator. Negative 1 minus radical 3 and 1 minus radical 3. So when we do this, we need to rationalize our denominator. So when we rationalize our denominator, we multiply by the conjugate of the denominator, which will give us this. So let's multiply that out. I get a -1 minus radical 3 minus radical 3, not a plus, minus 3 over 1 minus 3. So when I finish this up, I get a -4 minus 2 radical 3 all over a -2. And if I factor a -2 out of the numerator, I get this. And now my -2's reduce out, so I end up with 2 plus the square root of 3. Okay, so that took up way more room than I left on my screen. So I'm going to go ahead and erase the last couple of lines so I can get my next problem in. So now it says I need to find the sine of 13 pi over 12 pi. Well, now I have to find two angles that add up to 13 pi and 12 pi. So I don't really necessarily know what those angles are. So I'm going to just try a couple. I know that I have, let's see, well, they could actually subtract too. So maybe if I have 5 pi over 4 and I subtract a pi over 6, I know the denominator would be 12. So let's see what this does. I have over 12, and I'm probably just going to get lucky here. I'm going to multiply that by 3, so that's 15 pi over 12 minus 2 pi over 12, so that's 13 pi over 12, which is exactly what I want. I'm sure there are angles that add to 13 pi over 12. I just happen to think of two angles that subtract to 13 pi over 12. So I'm going to go ahead and use those two angles, and I'm going to use a nice difference formula for that. So my difference formula is going to be the sine of 5 pi over 4 cosine of pi over 6 minus the cosine of 5 pi over 4 sine of pi over 6. So I know the sine of 5 pi over 4, that's going to be a Q3 angle. It's going to be one of my 45-degree angles. That's going to be a negative radical 2 over 2. Cosine of pi over 6 is going to be radical 3 over 2 minus cosine of a 45-degree angle is radical 2 over 2 in quadrant 3 is going to be a negative radical 2 over 2 times the sine of pi over 6 is 1/2. So when I multiply that out, I get negative radical 6 over 4 plus radical 2 over 4. So I never like my negatives in front, so I'm going to switch my two terms to get this. All right, so sometimes when you pick angles that add or subtract to a given angle, you get an answer that doesn't match the back of the book. If that's the case, I would like you to plug your answer into a calculator and calculate it out. Plug in the answer that you found in the back of the book into a calculator and calculate it out, and if they match, your answer equals the book's answer. All right, so let's move on to our next one. We have a whole bunch of other problems that we're going to do. So I need to find two angles that either add or subtract to 5 pi over 12. So let's do pi over 4 plus pi over 6. We'll test that out. That's going to be 3 pi over 12 plus 2 pi over 12. That's going to work. So this is going to be the tangent of 3. Let's do pi over 4. Let's write it as pi over 4. pi over 4 plus pi over 6. Okay. So we're going to get the tangent of pi over 4 plus the tangent of pi over 6 all over 1 minus the tangent of pi over 4 tangent of pi over 6. All right, so I need the tangent of pi over 6, so that's a nice 30-degree angle. So this is 30 degrees. So the tangent, this is going to be 1, 2, and radical 3. So the tangent's going to be 1 over radical 3, which is radical 3 over 3. All right, so the tangent of pi over 4 is 1. The tangent of pi over 6 is radical, well, let's just use radical 3 over 3. And then in the denominator, I have 1 minus 1 times radical, well, that's a plus, sorry, radical 3 over 3. So let's multiply both the numerator and the denominator by 3 to get rid of my complex fraction part. So I get 3 plus radical 3 over 3 minus radical 3. So now let's multiply by the conjugate. So that's going to be 3 plus radical 3 over 3 plus radical 3. So we get 9 plus 6 radical 3 plus 3 over 9 minus 3. So when we reduce or add or combine like terms, we can factor a 6 out of the numerator. And then our 6's are going to reduce out, and our final answer is going to be 2 plus radical 3. All right, I probably have time for one more problem, and then I'm going to create another video for the rest. Okay, two angles that subtract or add to negative 5 pi over 12. Okay, I think we've already found them. Up here, we had two angles that added to 5 pi over 12, so I'm just going to make them negative. So I'm going to have a negative pi over 4 minus pi over 6. This is my A. This is my B, and I'm going to use my subtraction formula. So I get the sine of negative pi over 4 cosine of pi over 6 minus cosine of negative pi over 4 sine of pi over 6. All right, so my negative angles, my negative angle identities tell me that sine of a negative angle is negative sine cosine of pi over 6. So my negative angle tells me that cosine of a negative angle is just the cosine of the positive angle. Pi over 4 sine of pi over 6. So I know that negative sine of pi over 4 is radical 2 over 2. Cosine of pi over 6 is radical 3 over 2 minus radical 2 over 2 times 1/2. So this is going to be negative radical 6 over 4 minus radical 2 over 2. I'm just going to join it into one fraction. Oh, that's a 4 over 4, and I'm done. So the next couple of examples I'll do on my next video.